Everyone, welcome back. So this is part 4 of machine learning course. Today we will be starting our introduction to programming. So we will be covering like how to create your first program, how to approach any programming language which you want to learn and move forward. And also I will be covering some basics of Python as well required for machine learning and how you can use them in advanced topics as well. So it doesn't matter if you know any Python or not, if you know any other programming language or not, we'll be starting from the complete scratch and more we'll be focused on like how you can learn any language in an appropriate way so that migration to another one doesn't sound that much difficult. Um, just to give a brief overview, like I have learned Java, C++, Python, and coded in C as well. So if you know the basics of any one language, migration to others becomes super easy. So that's why mastering the basics of any programming language or the approach is very crucial. So let's start with it. Okay, so this is the list of the topics we will be covering in this video. Now, before starting any language, the most important question that should arise in your mind is why do we need a programming language to communicate with the computer, to communicate with the machine exactly? So, what happens before any programming language was made is the people used to write the code in machine language. So, if you just take a look, sample machine language code. Yeah. So every communication you do is via this numbers, alphabets, hexadecimals, we can basically say. So it is very, you can say, hectic. And suppose if not any programming language was made till date, what most of the users, most of the engineers will not exist. Like to code in such machine language is really hectic. So that was the reason um, the programming languages were started to make. So the first language was C, then arises difference and so on. So what they do, any programming language, let me take it down in the notes as well. You write some code, it has some compiler or an interpreter, and what it does is it converts your code into machine language. So that compiler or interpreter, what they do is they convert your code into machine language. So that's why while learning any programming language, it is really important to focus on the syntax in very minute details as well. Like for Java, if you miss a semicolon, it raises an error. Like you will be wondering why. Because the compiler fails to interpret the other lines if you miss the semicolon. So that's why there are some rules that comes with every programming language that we needs to follow to ensure like our compiler, our interpreter is able to understand what we wanted the machine to do perfectly and thus pass the instructions in that manner only. So that's why there are some rules. Now your code compile into machine language. So some languages have compiler like C, C++. Some languages have interpreter like Python, which you are going to study. And then there comes Java, which have both compiler and interpreter. So that's the some unique of Java, which makes it platform independent. Okay, now you know why we write code, but how we write code, any code, like if you are given any problem, there are two most common methods in programming language to solve them. One is algorithms, and then other come flowcharts. So what's the issue with algorithms? Like it's some instructions to solve a particular program in human language. So let me just give you an example. Suppose if you want to add two numbers, that's your problem of the day. Or suppose if you want to make some food, make some tea. So what should be the step? You follow the step-by-step cycle. So gather two, numbers, you take the two numbers, then what you will do, you will add them and then display them. Similarly, if you want to cook food or do anything, like suppose if you want to cook some basic meal, so what will be the sequence you follow? You will gather all the ingredients, then you will prepare the ingredients, cut them, peel them or whatever. Then you will cook the ingredients. Then after timeout runs, you will pour the ingredients into the dishes and then eat. So everything, every problem which you are solving, even the simplest of one, you have to follow the sequence of steps. So these steps written in the normal language are called algorithm. Like what are the steps I have said? These will be your basic algorithms to cook a particular dish. Now then come flowcharts. Um, Flowcharts which we will take some sample from here only. Sample flowchart diagram. Let's take some easy one. Yes. Suppose if you want to go to school, what you will do? It will not get okay. Copy there. Suppose if you want to go to school, so this you are starting. There are some rules for drawing a flowchart. In the ellipse, you form the starting and the ending terminating statement. Then all the steps, like the input you have to take, the output you have to give, should be in parallelogram. And in the diamond comes all your condition. And in the normal rectangle bus, your all action steps. So start. What you will do, you will first check time, take time as input, and you will check. Then comes the check conditional statement. If it's before 7 a.m. or like after 7 a.m. when you're leaving the home. If it's 7 a.m., you are late for the school, you will take subway and then go to school. If it's before 7 a.m., you can take the bus and then go to school. Like this is the simplest flow chart. So for any numbers, like if you take the example of add two numbers, start, take two numbers input, no conditional statement, just a simple add two numbers, then a parallelogram, display result, and simple. So these are the steps which you will follow for complex programs. Like if you're giving something that is really complex, you will divide that into algorithm, you will divide that into flow charts at enterprise level, I'm talking, to solve these situations. Now, um, okay, so here we are done with like why do we require a coding language? What are the needs of it? Why it was built? How how you tackle a particular program which comes in front of you. Now comes the actual learning part. We are starting with Python. So for documentation, who made it, whatever it is required, you do not need to learn it unless you wish to appear in some cases or like that, which is not required. But okay, what does Python do? Um, I've studied Java for more than 6 years, but still, if you're learning ML or AI, anyone will blindly recommend Python who has done it. Why? Because it has all the libraries, all the functions, all the methods required to make a program. What are libraries? What are these things? We'll discuss them later on as the course proceed. But okay, take it like that. Like Python acts as a storeroom which has everything you require for machine learning there. But you need to search into it. You need to know like where to look for a particular thing if you want to if you want your code to execute a certain action. So that's where the knowledge of Python comes in handy. Starting with basics. This is the Python documentation. Um, okay, starting with the installation. You do not Python install PyCharm or like any language like VS Code, or you can directly install there and then you can open that in Python as well. And here you can open them here as well, just a standalone. So um, like okay, we'll go through a sample program in some time. But okay, this is the installation part. And just to be clear, go there, download Python. Don't download these versions. Download like the latest, like 14 you can download or 16, which are the stable one. Specific release like yeah, 14 you can go for it. And now comes, okay, if you're starting with Python or any programming language, now comes the important part. How do you write a program in it? So let's say um, for writing a particular program, you have to understand some basic concepts of it. So each language have variable, keywords, constants, operators, comments you can say, and okay, whatever. These stuff we'll be covering them later on. So this, I know this is all just theoretical, but you'll need to understand these things in clarity before moving to the actual stage where you will be writing the code. So what are variable? Um, anything variable, okay, container to hold a value and a star must not be a keyword. So okay, keyword is the most basic. Let me just give the definition for keyword first. Use the words of any language. So as I told you earlier, like what our compiler interpreter do, it reads the code and converts into the machine language code. So each compiler or interpreter has some specific words from Lexer or parser, which you will study in compiler design if you ever go. So what they do is they have some specific keywords reserved for them. Like if else in many programming languages you might encounter later on, print in Python, system.out.println you have studied in Java. So class, like these all keywords, each language have different set of keywords for them. So these keywords are the reserved words for any language. You do not use keywords as variable, as constants, or anything else. Like they're reserved. Now comes the variable. Um, what are variable? Container to hold a value. Like it's that very simple. Let x is equals to 5, which you write in maths most of the time. So any container which holds a particular value is called a variable. Constants are variables whose values do not change. So you can define them by const in many languages. In Python, I think yeah, you can define them by const as well. So and you can do other stuff as well. So constant whose values don't change. Operators are basically operators perform operation on operands. Simple. Operands and operators you have studied in maths as well, like 3 plus 5, 3 and 5 are operands, plus is the operator. So what are the different kinds of operators? Arithmetic operators are plus, minus, divide, multiply. Multiply is by asterisk in programming languages. In Python, you have ceiling divide, like 5 divided by 3, it will give you 1.66, but this will give you 1. Like it will ignore the fraction part out after it. And then here comes modulo, like 5 modulo 3, it will divide and give you the remainder, which is 2. So arithmetic, logical we have, and or not. Don't, like it's just as simple. Like if you have studied in basic logical or electronics, which I have told you in the previous sections as well. And what does M do? If both the statements are true, then true. If both are false, if both the statements are true, then only true, otherwise false. And for or, if both the statements are false, then false, otherwise true. Not it just simply reverse your result. Relational is something like hmm, greater than, less than, greater than, equal to. less than equal to compares the object, equal to compares the exact value of the objects, not equal to. So these are some relational operators which will perform. Um, and what are the operators also? Ternary operators is very simple. You have, so let me just give you condition. You write some condition here. So question mark comes first. Statement 1, statement 2. What happens? Condition true. Then it will go statement 1. Otherwise, statement 2. This is that simple. For ternary operators, yeah. And comments are like single line, and then you can do multi-line comments, somewhat like that it ends, or might start up and down. Yeah, these are just some basic of the things which you should know while learning any language. So, what are the operators, key variables? Like, okay, now let me take you from the program. This is your variable. You're assigning it some value. B is equal to, let's say, 3. So A plus B gives 5. A minus B gives 2. A multiply B gives 15. A divided by B gives this. Floor division gives this. And modulo gives 2 as well. So, yeah, really simple. And A greater than B true. A less than B false. A greater than equal to B true. A less than equal to B false. A equal to B false. Invalid syntax. Yeah, okay, sorry. Um, is not equal to B is not equal to B true. Yeah. So that's how you can go and study all of these things. And yeah, let me give you an example of the ternary as well. A greater than B, then print A, otherwise B. Oh, okay, not print A greater than B. Print A, otherwise print B. What's calling syntax error? What if you do inside this B, B? Um, it has some value. Okay, might be required some file to import or do anything. But yeah, this is the core logic behind whatever we have to do, and the syntax we have to follow is okay. Um, if you're given any particular code, like let's say take the lead code, the most simplest one, to some like the two numbers. Some you are given an array. Okay, this is something which you have to cover. But okay, data types, yeah, data types comes in very handy. In Python, you don't encounter very much with your data types as well. But what are data types for any language? Um, like let's say suppose what do variables do? Variable act as your container to store a value. But how does your container know what kinds of value it is going to receive, and how much memory does it have to allocate with it? So let's say that's a very important knowledge when you have to do optimizations at the deepest level to ensure like the data you are choosing to store a particular value should be optimized and should only contain that much value as only. Um, Let me just open. We have all like six different kinds of user-defined and normal data types in Python. Yes. This is the most simple diagram which we can see. Okay, so let me just take you through what can be the different types of container. One should be your numeric, simple. Then dictionary. What is dictionary? We'll come it later on. Then you have your Boolean, then you have your sets, then you have your sequence. Sequence is something which is predefined. Um, but okay. And then you should also have some string. It's not given. Okay, string is given in sequence. Yeah, okay. Strings you can say a sequence of arrays, characters, character. So numeric, how much numeric data type you can have? So it's different for different languages. Um, in Python, it's just only have integer for like numeric whole numbers. Like in Java, you have byte, short, int, long. Like you are optimized till byte. If you require some character to only have minus 127 to 120, minus 120 to 127, you choose byte and so on. In Python, you have numeric. You choose integer data type. Integers are number like minus 2 plus whole numbers, like which are not in decimal. So numeric complex numbers you have studied in your class 11th and 12th, which are in the form of okay, numeric integer. Let me just give you an example. Um, Complex a plus iota b. And what is iota? Under root of minus 1, imaginary. Just like a lot of things, integer complex, and then you have float, which is in the form of 3.4. Now comes the memory part. Why are they differentiate? Why can't we store an integer in the float? You can. The thing is, the memory allocated for float data bytes is much larger as compared to integer. So what happens when you store your integer data type in the floats? It will store as minus 3.0, which is fine. But on the other hand, it wastes your a significant part of your memory, which can be comes in handy while storing the mantissa, like the fraction part. So to avoid this, we store the integer in integer data type, which are fixed like phone numbers, um, your house, your house address numbers, and a lot of things. So where integer are fixed, we store them as integers. Now comes in similarly for complex. Complex has the highest memory allocated to them. For dictionary, it is just a key value pair. That's simple. Um, okay, if we go there, here we have dictionaries that comes in under curly brackets. So let's just take the sample and paste it here. So what is the key value? Size is fat, color is gray. So um, let's say if you want to access a dictionary, like let's say we suppose we name it as X. So if we have to access the values for a particular key, then we can access it by X size. Then it will give us the what is the size of X? It's fat. My cat, age in years. Okay, yeah, you are adding something new. My cat size, it will give you fat. So, how do you use them in the codes and everything? We'll cover later on when we'll cover like all the samples of programmings. But for currently data types, you understand like it just hold key value pairs. You can access the value via keys. So key value pair takes it something like hash maps in Java. And okay, what problem does it solve? That is the question. So let's say you encounter a situation when you throw a dice and you have to calculate the result. How much time this number will occur? So let's say a problem comes up to you, you're calculating something. I'm just taking a sample. Like, okay, let me take a real life example. Hmm, like, let's say you are in a racing event. So, the thing that comes now is how much racers have finished their time between this duration. There are certain sets, like between 10-second interval from the first, between 10 to 20-second interval. So, you have to count the numbers. So, there comes the key value pair. You define the interval, then you add the value accordingly. Like if suppose we have one finishing that interval plus one finishing that interval plus one the original value of here. So by the end all the ratios finish, you have okay, how much ratios finish between this interval, you will get the perfect value. So the dictionary comes in handy and a lot more condition as well if you go real life. Now after dictionary you have Boolean. Uh, these are some of the most Boolean is one of the most important data type as you move ahead. Why? Because it has only two values, either true or false. And why it is that necessary? Like let's say, um, okay, in decision making, it takes the least one bit only. One bit is the smallest memory block you can allocate to anything. So one bit it can have only two values, like 0 or 1. One byte can have 8 bits, so you store that much amount in them. But for one bit, it have either true, 1, false, 0. So it saves a lot of memory when you have to do decision making. Now after that comes the set. Set is something which I've studied in maths as well, unique value. So set have something in like here it have only the unique values. So it doesn't matter how much value you keep on adding. If it encounters the same value, it will not add them. Like that's the difference between set and what we are going to learn further on, that are arrays. Like set have all the unique values. Arrays, like if you add the same value, it can have multiple values with the same reference. Like you can add 3 times in an array, but for set, all values must be unique. Like this is the property of the set which we have studied. All right. So yeah, it store all the unique values. So that comes in handy when you have to do a lookup for a particular value. So like let's say suppose you have a huge chunks of memory coming in from live stream. So like you are processing around 10 to the power 6, 10 to the power 7 bits per second. So you keep on processing the sets. And after sometimes like let's say like half an hour, you have to calculate, okay, how much different values do we have? So let's say the stream consists of some kind of data like 10, something like that. So at the end of the stream, okay, you must be 1, 2, 3, 4, 5, 6. It has 6 different values. All the stream goes and over it again. So that's how you can understand like what is the range of the values you're encountering and Like it comes in really helpful in solving certain problems also. Um, like this is what dictionary is okay. We'll cover all those samples, relax later on while we do the hands-on practice with all those data types with the perfect syntax and what are perfect what do we say data types as well and like everything. Sequence type. Okay. What is a sequence? Arithmetic sequence, geometric sequence, progression, like something that goes and on, like a continuation of certain values. So these sequence are of three types. Here, arrays. Arrays are just a group of similar kinds of data. Doesn't have arrays. Okay. String is the okay. Arrays are custom-made objects in Python. I forgot. What are strings? This is a random string. In double quotes, you can add single quotes. You can add define multi-line strings as well. So combination of characters. Character data type. Okay, this is something I left out. Um, let me do here. Character, a single character take 1 byte, 8 bits. That's it. Like you define them in a single quote. B is a single character. Unicode character. Suppose if I'm not wrong, 65,000 something characters are there. Like it, they cover characters from all the scripts from many different languages. It's each have its unique code. So this is a character, like you have something right in Hindi, that is also character, and emoji it might also be a character. And just to give you reference, this is also a character, each having a their different SKY values. So capital A to capital Z have SKY values of 65 to 90, and small a to small z have SKY values of 97 to 122, 525, yes. And 0 to 9 have a sky values of somewhere in between. They should be like around, I don't know. Let's just search 0 to 9 a sky value 49 to 57. 0 to 9 you have 49 to 57. That's simple. um After you all of them, string, like combination of alphanumeric. It can have numeric as well, like in the double quotes. Anything you can type. The combination of like what are string? Combination of array characters. So it supports 65,000 characters, and you can have like 65 different types of characters enclosed together in a particular string. And list and tuple. This is a very important topic. Okay, yeah. So what we're going through, list and tuple. This is the one of the most basic and required topic. Okay, so let me just go there and control flow is something I've taken you through them. Yeah, we'll do them later on. Do statements and everything. Data type first is necessary. Yeah, distant was all. Um, so list is something as a collection. Okay, so you can associate array as something like list, collection of string, something like this, cd, numbers as well. So you can store all of that in the uh, list. So, okay, for each and everything, indexing starts with 0, 1, 2. And if you go to backwards, -1, -2, -3. So from the front, it goes to 0 to length -1, and backwards from -1 to minus L, which is the zeroth element. Sublist with slices, yeah, all these functionalities you can do with list. We will cover them later in detail. That might be in the second part, okay? But yeah, tuples are something which are immutable. List you do in um, square brackets. Tuple are immutable. What do you mean by immutable? Okay, let's say strings are immutable too. So what do you mean by mutable, immutable in reference to memory? So um, what are mutable objects which you can change their values or the components inside them while they are still inside the memory? Like list is mutable, so you can change the values. The list holds while it's still live. Okay. For an example, like if you have a memory, like let's say this is your memory, this is somewhere a particular list is. So suppose you want to change a particular value in the list, you want to make this 32. You can change that and nothing is harmed. But suppose there's a tuple here and you want to change a new value in the tuple. You want to change this 32 to let's say 22 back again. So what happens is the older one of the tuple stays there until the garbage collector collects the old reference of the memory, and then it creates a new tuple. All the elements are same, just one element changed. So, okay, why are tuples still useful like if they're immutable? Because as compared to the list, each element in a tuple consume less memory than the list as well. Like it, of course, if it provides more features, it comes in with some sort of disadvantages as well. So, like each object, everything you write in a program, each word you underline, each word you go through, everything has a meaning with reference to directly from the CPU, whether you related it to memory, the instruction, the compiler, or anything. Like whatever advancement is done, it has some direct connection from there. So of course, why do we use dictionary to store all of these values? I can't really store them directly because, of course, like to get them here. Um, that's all for list and tuples, set dictionaries and what all there. Um, like data type operators I've covered, and then we have loops and conditional languages. So this is more like theoretical. Then from the next, like from part two as well of this, we'll go through some of the exercises as well. So by the meantime, you can explore all the theoretical section, why Python was created, um, what all like operators do we have, what are the some basic syntaxes of the programming languages, what are different kinds of flowcharts we have, algorithms. There is something else to look out as well. What is the function of compiler interpreters? What are the latest compilers and interpreters that Python have? So take this as an homework. Study about like this in depth. What does compiler do to a particular code? How does it convert to machine language? This is really very interesting. If you go deep dive, you will come to know a lot of things about them as well. So for loops and conditional, okay, one important thing about Python is it follows indentation. How? If colon, next line your next line starts from there. Not from here. If you start here, it will be an error. Simple. So Python, if you have anything like function, okay, block and code of statements. Um, so let's say you define a function. What is a function? Okay, this one question arises, a good one. So let's say you are given a task to perform an operation. That comes the concept of object-oriented programming. which we'll cover in the second video as well. Mm, Let me mark that. Okay. It, it is in itself a complete topic. So, okay, like let's say your function. Um, you define some function. It performs the following task. Don't go over the syntax. This is not the actual syntax. I'm just writing it through. It performs a some simple task, and then you call that function. Like to do something here, like to add two numbers, you define a and b are given, return a plus b. So whenever you call that add function passing the 3 and 5 values, it will give you the final answer. So suppose if you have some large enterprise level of code where you have to do some of like not some exactly like you have to do 15 to 20 operations. So you divide each operation into function. In the main file you call only those functions and get their work done. So you divide the work in a particular manner. That will cover it in detail in the oops section as well. Let me mark it in bold so that we can remember what we have to cover. So this is for function and block of code. So if you define a function, then your next line will start from here. Is that? So if you're executing a certain block and you define variable inside that, so the scope of that variable stays in that block only. Like that's something like take it as class wise. So if you make a particular notebook for a particular class, the scope of the notebook, that notebook acts as a container to store data. So the scope of the notebook stays for that class only. If you switch class, you have to prepare a new notebook. But if you define a variable outside class, like let's say um, these are your friends, kind of. So they don't change when your class or functions change. These are your containers, like as soon as the whole program, as soon as the whole of school goes on. So take it as them. Um, so there comes the concept of loops. Loops, we have for, while, and do while we have it. Okay, we must, but yeah. So for what does for loop do? Um, it gives you a fixed number of iterations, like for I in range. Range is a predefined function, and let's say for I in range 5. So it has some starting value, ending value, step. Start from 0, move to 5 plus 1, 0, 1, 2, 3, 4. So for I in range that, print I. Simple. While here you gives a condition. While I is not equal to 100. Here you define I add some. So it is conditional based. It does not have fixed number of iterations like 4. And do what? Like do a particular operation, then check the condition whether we have to repeat that one or not. So let's say it comes in handy while you do banking transactions and so on. Like where you have to ask a certain set of questions to customer at least once. If they choose to ask again, then do it again. So yeah, that's the advantage of do while over while and for. Um, then we have the basics of like control flow statements if else. So simple is if condition is greater than B, what do you do? Print A, else print B. Simple. Then you can have nested elif. Yeah, you can add another condition as well. If both are equal, print A plus B, else print B. Then we have switch case as well. So if elif, else, these all the words you are seeing, these are some keywords. This is keyword, this is keyword, this is keyword. A and B, your variables, this is operator. You write conditions inside the curly brackets. This colon indicates that you have, like, this is used in conditional loops and value defining functions or anything. Like where you have to act in act indentation. Like you have to execute these statements for if only. If we don't follow indentation and suppose let's say I write C is equals to 5. So the scope of if is finished. Elif will raise an error like elif without if. So for like simple, it's completely logical, common sense. Like if you are using else, like if you are going towards plan B, your plan A should have failed. That's the main logic behind it. So elif will look, elif won't work if you don't have if. So it indicates like the section of is if is complete and we are starting a new block in the root directory. So that's where indentation comes in handy. When you want to execute a particular segment of that code for that block only, like as we see in the flowchart, if execute that block, else execute that block. So that's where the conditional comes in handy. Similarly, for looping, until loop is not complete, continue executing these block of statements. Similarly, we have the switch case, switch. We have some expression. Then we have case A, case, well, until these values are finalized. Then we have default. So if the value of the expression goes with this, it will continue to execute from this case until what is found break statement. What are break and continue? We'll also cover them here as well. So as the word suggests, break, what does break do? While any loop iteration is going on, it will terminate the loop at that point where it encounters the break keyword. For continue, it's like suppose if it has iteration number 2 and it has to complete 5 iterations. So what does continue will do? It will at iteration number 2, it will complete the rest of the iteration there and then moves the counter to the next iteration, that is iteration number 3. So until break is encountered, starts executing from this case. If value 2 from this case. If none of the value, then default. This is some logical common sense. So this is some of the basic syntax, what all the things we are using in Python as of the basic level. So from the next, we'll be studying the implementation of all of these along with OOPS. That has to be one of the most important building block of your programming like journey. OOPS, it is asked in every interview, wherever you go, for any of the language type you are asked for examples as well as um, like how you implement those in real life scenarios in production level codes. So that is one of the most important aspect. And all of these are building blocks, like whatever code we are going to write, all of these things will be included in that. Like suppose while writing for simpler programs, you don't think of those things, how compiler works, how memory works, how runtime works. But okay, so yeah, whatever we do by default, and like if you are doing code, you should be able to understand what does each line do to the memory reference, how much time does each line takes to execute, and why. What can I optimize in it? What can I do so that this segment of the code moves faster while working for my personal application as well. So when you start thinking at that level, that's when your knowledge will be at the level of competing with the AI by the time you learn all the skills. So, by the pace the AI is growing, you should be able to now identify each and every aspect of single line, single word, what you're writing in the code, what AI is writing in the code, what impact does it have on the memory, what impact does it have on the runtime, is it writing the correct code, is it the most optimized code for that particular problem, can we break into the solution furthermore. So all of these comes information comes in handy if you like take it at the deepest level. So that's now for introduction to programming with Python. We'll cover like the demo of all these in the next, along with OOPS. And OOPS, what does it stand for? Object Oriented Programming. As the name suggests, it is one of the most important section um, moving later on. So yeah, that's all for this. Learn about whatever it is taught. Go deep. Try to understand most of the things on your own, like what are different type of data, what are the data types, how much memory does each data type consume, and how to write a simple program in Python. I have told you, like just a simple try writing 1 or 2 line of programs. If you're stuck, um, come and share, and then we can discuss the approach. Like, okay, uh, you know what to write, but you're not able to write in the language of the Python. That is okay. That is the beginner's problem. While you write code a certain number of times, you will be able to execute that perfectly. So, yeah, try to understand each and everything, go through them in detail. Most of the many things we will be covering in the next video along with demo. Uh, so, continue to learn and take care. Bye bye.